Hello everyone, let us start with our new chapter. The chapter name is Ordinary Differential Equation of First Order and of First Degree. Okay, before that, this is a differential equations chapter. It's a full of derivative and integrations. You have to mug up all the formula for derivatives and basic formula for derivatives and integration. Before that, let us see some of the important formulas. Let us recall all these formulas. Integration formulas, derivative formula we easily remember, but some integration formula we have to recall. X raised to n integration is x raised to n plus 1 upon n plus 1. N is any number, any fraction. Okay, e raised to x integration is e raised to x, e raised to ax integration is e raised to x upon this derivative of this indice is a. Tan x derivative is log of sec x, integration of cot is log of sin x, integration of sin hyperbolic is cos hyperbolic, integration of cos hyperbolic is sin hyperbolic, integration of sine is minus cos, integration of cos is plus sine. Integration and derivative are the reverse process, that's why plus minus sign are according to that process only. Okay, now integration of sec x tan x is sec x, because these are the derivatives of these terms. Okay, sin x derivative is cos x derivative is minus sin x, that's why minus sign is there for integration of sine. Sin hyperbolic, cos hyperbolic, for integration and derivative there is no matter of sign, because both derivative integrations are plus. Okay, integration of cosec x cot x is minus cosec x, integration of these are the formulas. Integration of f dash x upon fx is log of fx. If denominator contain one function and numerator contain its derivative, then integration becomes log of this denominator fx. Okay, these are the formula. Integration of f dash x upon root of fx. If root is there to the denominator, the difference between these two, the integration becomes 2 root this fx as it is. Okay, 1 upon x integration is log x. This is u into v rule. There are two formulas where we can conveniently use one of these formulas. U into v rule, u into integration of v minus integration of this integration of v into derivative of dash means derivative of u into dx with respect to dx. This is the formula where we have frequently used in 12th standard or in M1 also, some sort of examples. And this is the generalized formula for u into v. In some examples we are going to use this formula. Integration of u into v is u into integration of v1. Suffixes means integration. 1 2 3 means first integration, second integration, third integration, and so on. Dash means derivative. For one dash is single dash means single derivative, double dash means double derivative, triple dash is triple derivative, and so on. U v1, u into integration of v minus alternating plus minus sign, plus minus and plus minus so on. U dash, take the derivative of u. Okay, u dash, u double dash, u triple dash, and take on the integration of v1, v2, v3. These are the integrations of first integration, second integration, third, and so on. Until we get 0 in this series, we have to go by this some formula. Okay, in some example we are using this formula, in some example we are this conveniently using this formula. Index dash means derivatives, suffixes means integrations. Okay, log a into b or log x into y is log x plus log y. These are the basic formulas. Log x upon y is log x minus log y. E raised to log x, when e and log comes together, e and log gets cancelled, and answer becomes only this number x, whatever the number or expression or in terms of variable present after this log, it becomes that only. E and log gets cancelled, it becomes identity function, and identity of any function becomes that function. Okay, e raised to n log x, again log m raised to n is this indice comes to the before log, n log m. Similarly, this n can be taken to this indice also. Okay, then e raised to n log x is e raised to log this n comes to the indice of x using this property, and e and log gets cancelled, answer is only x raised to n. In some examples we are frequently using or doing this process. Okay, doing this step. Now let us start with the chapter. Linear differential. The first point of this our chapter is linear differential equation. Definition of linear differential equation: if any kind of equation like in this form where dy by dx plus py is equal to q, then such type of equation is known as linear differential equation. Okay, where y and x are variables and p and q, this is y here. If it is y here, then it should be y here also. Okay, and p and q are functions of this denominator variable x. Okay, dy by dx plus some function of x into y is equal to q. Such type of differential equation is called linear differential equation. Okay, now how to solve this linear differential equation? It has a particular formula. Before that, we have to find out the integrating factor. What is integrating factor? Short form as if. Everywhere you can use this word if. Integrating factor is equal to e raised to p dx. E raised to this p, this whatever the function of x here, we have to put here e raised to p dx. This is the integration we have to solve. And after finding this integration factor, integrating factor, the solution of the linear differential equation becomes y into this integrating factor, put this value here, is equal to integration of this q here into this integrating factor into dx plus c, where c is obviously, after calculating integration, c is nothing but integration constant or integrating constant. Okay, now let us start with the examples. After solving example, you will easily understand. First, solve the throughout the chapter, just solve. Okay, the question is just solve the given differential equation. Means we have to find out value of y by using different methods. First, we are going to see the linear differential equation. dy by dx plus 2xy is equal to 2 e raised to minus x square. Okay, now compare this equation with this equation. Comparing with this equation, what is p? We have to find out p because we have to find out the solution consists of integrating factor. Or for integrating factor, we have to find out p and here q. That's why comparing these two equations, what is p? P is nothing but coefficient of y here in this example. What is coefficient of y? 2x, including plus minus sign whatever it is present here. Here 2x is there, that's why p is 2x, and q is on RHS side, q is there. Whatever the function, including plus minus sign constant everything, q is 2 e raised to minus x square. After finding out p and q, we have to first find out integrating factor of this particular linear differential equation, because this is a linear differential equation. Okay, now integrating factor becomes by formula e raised to p dx. E raised to, put the value of p here, 2x dx. 2 is a constant, take outside, x dx, where integration of x is x square by 2. 2 gets cancelled, it becomes e raised to only x square. Once we find integrating factor, put this value in the solution. Therefore solution is y into integrating factor. Everywhere you have to write this step and this step. Okay, everywhere in each and every example. Now solution is, this is the solution statement. Y into integrating factor is equal to integration of q into integrating factor dx plus c. Put the values of q and integrating factor here. We get y into this e raised to x square is equal to integration of q. Q is here 2 e raised to minus x square into integrating factor is e raised to x square dx. And e raised to base is same, index should be add, minus x square plus x square gets cancelled, e raised to 0. Anything raised to 0 is 1, that's why integration consists of only 2. And 2 take outside, integration of 1 integration is x. Therefore answer is y e raised to x square is equal to 2x plus this integration constant c. Okay, this is called the linear differential equation and with the solution method. Okay, let us move to the next example. For that you have to mark up all the formulas. Okay, cos square x dy by dx plus y is equal to tan x. Now if you see this equation, for linear differential equation we need dy by, how to recognize this particular example is of linear differential equation, we have to just mug up this statement. We need dy by dx single, p into y, here y should be there, and rest of the terms should be function of x. Okay, here we have dy by dx coefficient is not 1. That's why first step will be divide the throughout equation by cos square x. That's why first step will be divide by cos square x. We get dy by dx plus y upon cos square x is equal to tan x upon cos square. Okay, now simplify. 1 upon cos square is reverse of cos is sec square x. This y as it is, tan x as it is, 1 upon cos square becomes again sec square. Okay, this is now our linear differential equation. LD, you can put it as LD. Okay, now comparing with this equation, is with our given equation, what is p? This is now in our format of LDE, linear differential equation. Now this is our p, coefficient of y is p, and q is RHS side expression, that is tan x square x. Now we have to find out integrating factor. Integrating factor is formula is e raised to p dx. Put the value of p here. We get a sec square e raised to sec square x dx. Integration of sec square is tan x. Okay, integrating formula, you have to mug up all the formulas. Here one more formula we have missing here. Integration of, write down wherever possible here, or integration of sec square is tan x. Okay, okay, now integrating factor is e raised to tan x. Now solution is, formula is this: y into integrating factor is equal to integration of q into integrating factor dx plus c. Now put the values here. Y into integrating factor is e raised to tan x is equal to q into, q is this tan x sec square x, and integrating factor is e raised to tan x dx plus c. Now put this value, call this equation number 1, because we have to solve this integration. Integrating this integration can come by any method. Okay, you have to solve this by any method. That's why here tan x, I mean, we know tan x derivative is sec square x. That's why it is an example of substitution. Now put the value of tan x is equal to t. Take the derivative on both sides, we get tan x derivative sec square x dx becomes dt. Now put these values here in the equation, we get y RHS side, LHS side as it is, integration of e as it is, tan x becomes t, tan x again becomes t, and sec square x dx becomes dt plus c. Okay, now this integration is very easy using u into v rule. This is the u into v rule, we can easily solve. How to find out u, what is u and what is v? By Liet rule. L is logarithmic, I is inverse function, sine inverse, cos inverse, like that. A is arithmetic, x square, x cube, 1 by x square, like that. T is trigonometry, sine, cos, tan, anything. E is exponential, e raised to and a raised to anything. E raised to is a last one, that's why it is v, this is u. Put now go on putting this u and v into this formula, we get u into v1 means u into integration of v, that is u, t into integration of e raised to t is e raised to t, minus, this is minus, t is derivative here, u dash means derivative of u, t derivative with respect to obviously variable t, everywhere the in this particular example, in this particular integration, variable is t, t derivative is 1, again v2 means second integration of v, means first integration of v1, go on take integration of this, that's why v2, this here will be the integration of this first, e raised to t integration is e raised to t. Now plus u double dash means one derivative is 0 because it is a constant, that's why this process stops here, plus this integration constant c as it is. Now simplify, e raised to t get common, t minus 1 as it is. Now resubstitute the value of t, because t is our variable, in the we are assuming t as tan x, that's why I put resubstitute here as t as tan x, and therefore final solution is this. Okay, now let us move to next. E raised to minus 2 root x upon root x minus y upon root x dx by dy is equal to 1. Now we want this in this format, in our linear format, that's why take dy on that side, dx in the denominator, it becomes dy by dx becomes this term as it is. Now which term we have to take on LHS side depend on the our uh, this format. Dy by dx should be on LHS side, and the term which consists of y should be on LHS side. The which term out of these two term consist of y is this term. That's why this term should be moved to LHS side. That will be become our linear differential equation. Okay. Therefore, next step will be take this term on this side and this as it is here. We get dy by dx plus dy by dx plus this term, it becomes reverse, y upon root x is equal to this term. Now it becomes with our it is exactly matches with our linear differential equation. Therefore, comparing with this equation, we get p is nothing but y coefficient is 1 upon root x, q is nothing but RHL whole side, RHS side. Now consider integrating factor. Integrating factor is e raised to p dx is equal to e raised to this 1 upon root x dx is equal to now we have to find out integration of 1 upon root x. Root x means x raised to half, and take to the numerator we get x raised to minus half, and apply the formula for x raised to n. What is that formula? X raised to n plus 1 upon n plus 1. Minus half plus 1 is half upon same number half. Now this half, this 2 comes to the numerator to this. We get e raised to 2, x raised to half means root x. Okay, this is the final answer for integrating factor. Now put this value in the solution. Solution is, this is the statement of the solution as it is, y into integrating factor is equal to q into integrating factor dx plus c. Put this value, we get y into integrating factor is this, is equal to integration of this integrating factor into q. Q is this total term. Okay. Now again you will see exponential into exponential, base is same, indices should be add, indices are same but opposite in sign, therefore e raised to 0 we get, and e raised to 0 is 1 upon this root x as it is, and again 1 upon root x integration we have just solved here, 2 root x, no need to solve again, it is the same example, that's why answer is this. Okay, plus c as it is, don't forget this c because it is very important, it is an integrating constant. Let us move to next. 2y dash, in some example y dash means derivative, that's it, with respect to other variable, that is x. Instead of, apart from y, only x is there everywhere, that's why the independent variable is, the numerator variable is called dependent variable and the denominator variable is called independent variable. Okay, because we are taking dy by dx means derivative of y with respect to x, that's why derivative of y is depend on x, and x is an independent variable. Consider the next example, that is 2y dash means derivative with respect to x, 2y dash cos x plus 4y sin x is equal to sin 2x. Given, this is the extra information they have given to find out the integration constant c. Given y is equal to 0 at x is equal to pi by 3, we have to put these values after finding the solution. First let us consider 2 cos x as it is, y dash means dy by dx plus this as it is. Now for that to make this equation linear, we have to make this coefficient 1, that's why divide this equation by 2 cos x, we get dy by dx plus 2, 2 gets cancelled, 2 remains, sin x upon cos x is tan x into y plus sin 2x upon 2 cos x. Again sin 2x formula we know, sin 2 theta is equal to, or 2x is equal to 2 sin theta cos theta. Put this value here, we get 2 gets cancelled, cos gets cancelled, only sin on RHS side. Now this becomes linear equation, and p is nothing but, by comparing this equation, write down this equation in every example, p is equal to coefficient of y, that is 2 tan x, q is RHS side sin x. Now we have to find out the integrating factor. Integrating factor is e raised to p dx, put the value of p, that is 2 tan x, and integration of tan x is log of this. Integration of tan x is log of sec x. Therefore it becomes 2 as it is, e raised to log of sec x. Now take the 2 on the indices of sec, we get e raised to log of this sec square x. Sec x square or sec square x are both the same. Now e and log gets cancelled, that's why it becomes only sec square x. Now solution is, this is the formula for solution of LDE. Put the values of integrating factor here and q, that is RHS side sin x, sec square x dx plus c. Okay, now we have to solve this integration. Sec is 1 upon cos, that's why sec square is 1 upon cos square. Now sin upon cos, 1 cos given to sin, that is sin upon cos, and 1 cos remain as it is, that is 1 upon cos. Sin upon cos is tan and 1 upon cos is sec. It becomes sec x tan x, and integration of sec x tan x is, we know, sec x plus c. This is the LHS side, this is the solution. Okay, now one more question they have asked. By solving this equation, you have to put this value y is equal to 0 at x is equal to pi by 3. Put x is equal to pi by 3, that is pi by 3 means 180 by 3, that is 60 degree, and y is equal to 0 in this solution. We get y into 0 into anything is 0 is equal to sec pi by 3 plus c. Sec pi by 3 is 1 upon cos pi by 3. Sec is not there in the calculator, that's why I converted into cos. Cos pi by 3 is, instead of 180 by 3, you can directly put cos 60. You get half or 0.5. Take 2 on the, this 2 comes to the numerator. Answer is 2 plus c is equal to 0. Therefore c becomes 2 comes on LHS minus 2. Put this value c in this equation. Solution, we get y sec square x is equal to sec x minus c, that is minus 2. Okay, now let us see next example. dr, instead of x and y, here r and theta are the two variables. dr plus this bracket 2r cot theta plus sin 2 theta into d theta is equal to 0. Now to decide whether this equation is linear or not, linear equation is this is our linear equation, dy by dx. Instead of y and x, the other r and theta is there. We have to verify where dr by d theta or d theta by dr we have to make. If you make d theta by dr, this coefficient bracket cannot be come on the RHS side. That's why dr by d theta is a proper thing. And one more thing, in dy by dx, y term should be there. Here r term is there, theta term is not there. That's why dr by d theta we have to adjust in this particular example. For that, divide throughout by d theta. We get dr by d theta plus this term as it is equal to 0. Now in this equation, only y term is on LHS side. Rest of the q means function of x only, denominator variable, that is denominator variable is theta. That's why whatever the only theta term should be on RHS side. Sin 2 theta is theta term, and r 2r cos theta consists of r. That's why this term keep on LHS side, and this comes to the RHS side, we get minus sin 2 theta. Now this is the linear differential equation. This is the linear equation. Now comparing, on instead of r, instead of y, r is there. Instead of x, variable theta is there only. Okay, therefore comparing the equation with the linear, we get p is equal to coefficient of r, that is 2 cot theta. Q is RHS side with plus minus sign, minus sin 2 theta. Now integrating factor is e raised to p dx is equal to e raised to p value is 2 cot theta. Cot theta integration is log of sin theta. Okay, cot theta integration is log of sin theta. Make sure you have to know every formula of integration and derivative as well. Now take this 2 on the indices of sine, we get e raised to log of sine square theta. Now e and log gets cancelled, answer is only sine square theta is our integrating factor. Now solution is, just make one difference in the formula for solution. Y, instead of y, r is there. Instead of theta, x, instead of x, theta is there. That's why solution is r into integrating factor is equal to integrating factor into q d theta plus c. Put this value is here. R into integrating factor is sine square theta is equal to integrating factor sine square into q is minus sine 2 theta. Now I have to solve this equation. Take minus outside and put the sine 2 theta. R sine square theta is equal to sine square theta. I'm gonna take minus outside, and sine 2 theta is 2 sine theta cos theta. We have to put that formula. We get R sine square theta LHS side as it is, minus outside. Now take 2 outside. Sine 2 theta is this formula. We get minus 2. Sine square into sine is sine cube theta cos theta d theta. Now we have to solve this integration. Most of the integration are of substitution type or straightforward formulas are there. Now we know sine derivatives cos, and cos derivative is also sine, but if you put cos as t, sine theta d theta will not come into dt. That's why put sine theta is equal to t. We take derivative on both sides with respect to take the derivative as usual. We get sine theta derivative cos theta d theta. Theta derivative is d theta. T derivative is dt. Put these values here in this solution. We get this LHS side as it is, minus 2 as it is, sine cube is t cube, cos theta d theta is dt. Okay. Now t cube integration is t raised to 4 by 4. X raised to n integration which should be applied here. Now 2 2 is 4 minus t raised to 4 by 2 plus c. Again resubstitute t because t is our variable. It is not present in the example. That's why resubstitute t as sine theta. We get this answer. T raised to 4, that is sine raised to 4 theta by rest of the terms as it is. Therefore solution is this. Next example, cos hyperbolic x divided by dx plus y sine hyperbolic x is equal to 2 cos hyperbolic square x sine hyperbolic x. Now again we don't need this cos hyperbolic here. Coefficient of dy by dx should be 1. That's why divide the throughout the equation by cos hyperbolic x. We get dy by dx plus y sine upon cos hyperbolic is tan hyperbolic x is equal to 2 cos hyperbolic, 1 cos hyperbolic will cancel, and sine hyperbolic as it is. Now this is a linear differential equation. Now comparing with the linear, this is the p value is tan hyperbolic x, q is RHS side, total RHS side. Now integrating factor e raised to p dx, put the value of p, tan hyperbolic x dx. Now tan hyperbolic x integration is different. Okay. Integration of tan hyperbolic x is log of cos hyperbolic x, and integration of cot hyperbolic, if it is there, x is log of sine hyperbolic x. Okay. Normal tan and cot integrations are different. This integration is different. Now put this value here. We get log of cos hyperbolic x. E and log gets cancelled. Answer is only cos hyperbolic x. Now therefore solution is, this is the formula as usual. I into integrating factor is equal to integrating factor into q into dx plus c. Put these values here. We get integrating factor is cos hyperbolic x. Q is, this is cos hyperbolic x. Q is 2 cos hyperbolic x sine hyperbolic x. To take outside, cos into cos is cos square hyperbolic, cos hyperbolic square x into sine hyperbolic x as it is, dx plus c. Again use the substitution method. We have to solve this integration. Put cos hyperbolic x, again derivative of, we know formulas of derivatives. Sin x derivative is cos x. Okay, cos x derivative is minus sin x in the normal angle, while in hyperbolic angle this sin hyperbolic x derivative dash means derivative is cos hyperbolic derivative, both are same in sign, but cos hyperbolic x derivative is not minus, it is plus sign. Minus is not there in case of hyperbolic, in the derivative and as well the integration also. Okay, therefore put cos hyperbolic x is equal to t, take derivative on both sides, sin hyperbolic x dx becomes dt. Put these values here in the equation. We get y cos of periplic is equal to 2 into t square dt plus c. The integration of t square is t cube by 3. Again resubstitute t. 2 by 3 here. LHS is same. T is cos hyperbolic x cube or cos hyperbolic cube x plus c. This is the solution. Now next, move to the next example. X plus 2y cube into dy by dx is equal to y. Therefore, see, if dy by dx we put as it is, one more form of a let us see first one more form of a LDE. Okay, this is the normal form of LDE. Dy by dx plus py is equal to q, where p and q are functions of this denominator x variable and y should be there. The reverse, again if we reverse these variables, means instead of x and y, instead of x put y, instead of y put x. What will be the new form of a or alternative form of a linear differential equation becomes this. Instead of y we put x, instead of x we put y. Okay, plus p and q are the notation, that's why I don't remove that or don't change that. P as it is, q instead of y it becomes x and q, where p and q are functions of this y. Now instead of x this is y. Just reverse the term. Integrating factor becomes if becomes e raised to p, instead of dx it is dy, and solution becomes instead of y it is x, integrating factor is equal to integration of q as it is, integrating factor into dy plus c. This is the other form of a linear differential equation, where variables, in some examples we can change the variable for our convenience. Now let us see this example here. If we keep this dy by dx as it is, we have to take this bracket on RHS side. It will become in the denominator, which is not possible to make that form into our regular linear form. That's why take reverse form of this LDE, that is take on dx on that side, dy on this side. We get y into dx by dy is equal to this term as it is on LHS side, x plus 2y cube. Now this becomes the alternative form of a LDE, where instead of y x is there, instead of x y is there. That's why this coefficient of we need one more term to make this LDE. That is, for LDE, if y dy by dx is there, we need y term on LHS side. Like that, dx by dy term, we need x term, and apart from these two term, only x term is this one. That's why take x on this side, LHS side, and keep that 2y cube as it is on the RHS side, because this is y in the denominator and everywhere on RHS side y is there, x is absent. That's why this is our LD. Now again dx by dy coefficient should be 1. That's why our regular step will be but logical step will be to divide this equation by y. Okay, now this is the example of alternative form of a LD. That's why it becomes divide by y. We get dx by dy minus x upon y is equal to 2. 1 y gets cancelled, 2y square. This is our LDE, linear differential equation, where comparing the in linear differential equation in other form, that is dx by dy plus px is equal to q. Okay, now comparing this with this, we get p is equal to the coefficient of x. Coefficient of x is minus with sign minus 1 upon y, and q is RHS side, that is 2y square. Everything is same, just replace x by y and y by x. Now integrating factor is integration e raised to integration p instead of x, that is dy. Put the value of p, that is minus, take outside, 1 upon y dy. 1 upon x derivative integration is log x, that's why derivative of integration of 1 by y is log y. Now take minus means here minus 1 is there, that's why take on the index of y, we get e raised to log y raised to minus 1. E and log gets cancel, y raised to minus 1 means 1 upon y. Make the negative index as a positive by taking it into denominator. Now let us move to the solution. Solution is x into, instead of y we have to replace x. X into integrating factor is equal to integrating factor into q dy plus c. Put the values. Integrating factor is 1 upon y, q is 2y square. 1y gets cancelled, 2y, take 2 outside, x, this is x upon y integration is with respect to y is y square by 2. Again 2 gets cancelled, final answer is x upon y is equal to y square plus c.